All right, this is going to be our walkthrough for the homework assignment titled Newton's Method. So for Newton's method, we're just going to be approximating solutions to equations or roots to functions using a tangent line, essentially. So whenever we do this, I need to see a few things. I need to see the formula that you're using for Newton's method. I need to see your guesses as you go through. You need to list them out. And I need to see a good reason why you picked your first guess. So the first thing we're going to do is just set this equal to 0. Right, so just x cubed plus 3x plus 1 is equal to 0, which we know this function is a polynomial, which means it is continuous for all real numbers. And we know that we can find f of 0 really easily, right? F of 0 is just going to be equal to 1. And if we look for f of negative 1, right, we'll see that that's negative 1 minus 3 plus 1, which is negative 3. So we're going to want to take our first guess somewhere between 0 and negative 1. So our first guess as to what the root is going to be is just going to be negative 0.5. And then we also need our formula, though, right? Our formula for Newton's method, I'm going to write out the actual formula, not just for this particular function, but the generic formula first that we proved in class would work, was x sub n plus 1 is equal to x sub n minus f of x sub n over f prime of x sub n. And remember, we found that by just taking a guess at the x-intercept and then finding the tangent line of our function at that x value, finding its x-intercept, and just repeating that process over and over and over again. So for our function, since f of x is x cubed plus 3x plus 1, f prime of x is going to be 3x squared plus 3. And so what we'll do is we'll just put this into our formula, that x sub n plus 1 is equal to x sub n minus f of x sub n, which is x sub n cubed, plus 3x sub n plus 1 over 3x sub n squared plus 3. And what we're going to do is we're going to go to our graphing calculator here. And on our graphing calculator, we're just going to type in our first guess, which was negative 0.5, and we're going to hit enter. And then what we're going to do each time is we're just going to type in our formula, but instead of using the negative 0.5, we're going to use the answer button, which is secant, and then the negative sign. So we had x sub n minus, so answer minus. And then we had a fraction. So if your calculator has this functionality where you can hit alpha and then the x button right next to it to make it a fraction, please do that. And even if it doesn't look like it has that functionality, some of them do still, so test it out. If yours doesn't do that, then you're going to have to put the whole fraction into a set of parentheses, as well as put the numerator of the fraction in its own set of parentheses and the denominator of the fraction into its own set of parentheses. But I'm going to do it this way because I have that option here. So we're going to put in our function, which was the x sub n cubed, or answer to the third power. And then it was plus 3x sub n. So plus 3 answer. And then plus 1. And then in the denominator, we're going to have 3x sub n squared, or 3 answer squared, plus 3. We'll hit enter, and it should give us negative 0.3 repeating. And so what we'll do is we'll go back to our paper, and we'll write negative 0.3 repeating. And then we'll go back here, and we'll just type enter again, and it's negative 0.32 repeating. And what the calculator is doing is it's just reevaluating that same expression, just at the new x value. So now we have negative 0.32 repeating. And x sub 3 is going to be this value right here. So that's going to be x sub 3 is negative 0.322185355. And x sub 4 is going to be almost the same. Okay, we've got negative 0.32218535546. We'll do it once more to see that we end up with the exact same value, which means we can now stop, saying that x sub 5 is the same And that is our solution. So this is the process we're going to follow each time. Just in the interest of saving a little bit of time, I'm not going to write each of these down every time, but on the test for my class, you need to write them down. On the homework assignment, you can see in the answer key, I've written them down for pretty much all of them. I might have skipped it on some of them, but you need to write it every single time. Okay. So our next one here is going to be, when does sine x plus x squared equal 3? Right? Well, just set this equal to 0. Sine x plus x squared minus 3 is equal to 0. This will be f of x. F prime of x will be cosine x plus 2x. And so x sub n plus 1 should equal x sub n minus sine of x sub n plus x sub n squared minus 3 over cosine of x sub n plus 2x sub n. This time we don't have to pick a first guess. We're going to use x sub 0 is 1.5. And we don't have to show why, because I've given you an interval from 1 to 2 to think about this. So we'll just pick 1.5. So we'll go back to our calculator. We'll type 1.5 as our first guess, hit enter. And then we'll type in answer minus, give our nice little fraction here. We'll have the sine of the answer plus answer squared minus 3 all over cosine of the answer, and then plus 2 times x sub n, or 2 times answer. We get 1.419402095. I'm not going to write them down this time, so that's x sub 1. Here's x sub 2. Here is x sub 3, still changing. Here is x sub 4. Those two are the same. You would, of course, go through and write them all out, right? You'd put x sub 1 equals, x sub 2 equals, x sub 3 equals, and that was our one that worked, which was 1.418310092, and x sub 4 was the same. So that would be our answer. All right, for our next one, we have the tangent of x is equal to e on 0 to pi. So I'm just going to start with a guess of 1.5 again, because that's pretty much between 0 and pi. We're going to rewrite this as tangent x minus e is equal to 0. We'll call that f of x. Right? And f prime of x then will be secant squared of x. And so as we do this, we're going to rewrite this as x sub n plus 1 is equal to x sub n minus f of x sub n minus e all over secant squared of x sub n. Well, secant squared of x sub n is kind of annoying on our calculator because we don't really have a secant button on our graphing calculator. So I think I may rewrite this as x sub n minus, then I can just bring the secant squared up to the numerator, cosine squared of x sub n times the tangent of x sub n minus e. So I think I'll type that in. We're going to start with 1.5. We're going to do answer minus. And then we're going to have the cosine of x sub n. So we're going to put this in parentheses. The cosine of my answer. And it was cosine squared. So we'll do that. And then we're going to multiply that by the tangent of our answer, and then minus e, and we'll close that parenthesis. And this, when we hit enter the first time, ought to give us some value here. That's x sub 1. We'll just keep going. X sub 2, x sub 3, x sub 4, still changing, x sub 5, x sub 6, x sub 7, and x sub 8 ends up the same. So that will be our answer. It will be, you'll write all those out, but x sub 7 is equal to x sub 8, which is 1.218282905. All right, for our next one here, we're looking on the interval 2 to 3, so it just seems reasonable to start with a first guess of 2.5. We've already got this set equal to 0, so this will be f of x. F prime of x will be 4x cubed plus 3x squared minus 10x. And so our formula that we'll use will be x sub n plus 1 is equal to x sub n minus x sub n to the 4th plus x sub n to the 3rd minus 5x sub n squared minus 7 over 4x sub n cubed plus 3x sub n squared minus 10x sub n. And so we'll now just plug this into our calculator, starting with 2.5 this time. We have answer minus our nice little fraction here. And we had x sub n to the 4th. And we had plus x sub n to the 3rd. And then we had minus 5 x sub n squared. And then we had minus 7. And then in the denominator, we're going to have our 4x sub n cubed and we're going to have a 3x sub n squared. And we're going to have a minus 10x sub n. And so x sub 1 will be this. X sub 2 will be this. X sub 3. X sub 4. X sub 5. And it looks like x sub 6 is the same as x sub 5. So we've got x sub 5, which was the same as x sub 6, which was 2.11151883. And again, you need to write all of these ones in the middle out on your homework and on the test. All right, now we want to know when does the sine of x minus the sine of 2x equal 2 plus cosine x on the interval from 2 to 3. So we're going to start out with, I guess, 2.5 here, since that's between 2 and 3. We're going to rewrite this as sine x minus sine 2x minus 2 minus cosine x. And if we call that f, then f prime will be cosine x minus 2 cosine 2x. The minus 2 will go away, and then the derivative of negative cosine is a positive sine of x. This one's going to be kind of annoying for us to write out, I'm sure, but x sub n plus 1 is x sub n minus our original function sine of x sub n minus sine of 2x sub n minus 2 minus the cosine of x sub n. And then in the denominator, it'll be the cosine of x sub n minus 2 cosine of 2x sub n plus the sine of x sub n. We'll just plug this into our calculator, starting with 2.5. We've got x sub n minus our fraction. Our fraction was the sine of x sub n minus the sine of 2x sub n minus 2 minus the cosine of x sub n. And in the denominator, we had the cosine of x sub n minus 2 cosine of 2x sub n plus the sine of x sub n. And x sub 1 then will be this, x sub 2, x sub 3, x sub 4, x sub 5, and x sub 6 ends up matching perfectly. So we've got a bunch of terms here. Then we have x sub 5 is x sub 6, which was 2.755833558. All right, 3 more to go. These 3 are just a little bit different here. So we want to approximate the 5th root of 2, which means that we're going to want to come up with a function, a polynomial function, hopefully, that has this as a root. So the best way to go about doing that is just say, well, I want the solution to be x is the 5th root of 2. Well, if I take the 5th power on both sides, I get x to the 5th equals 2, or x to the 5th minus 2 equals 0. If I call that f of x, then I've got a polynomial who I can easily take the derivative of to come up with my x sub n plus 1 being equal to x sub n minus x sub n to the 5th minus 2 over 5x sub n to the 4th. And that should allow us, if we come up with a good first guess, to come up with a approximation for the value of the 5th root of 2. Now, we know that the 5th root of 2 is going to be between 1 and 2, right? Because the 5th root of 1 is 1, and the 5th root of 2 is certainly not more than 2. But we know that f is continuous because it's a polynomial, and we know that f of 1, right, is going to be negative 1, and we know that f of 2, okay, well, 2 to the 5th, right, is 2, 4, 8, 16, 32, minus 2 is 30. So we know we have a sign change here. So by the IVT, there is a root, right, f of x equals 0 somewhere on the interval 1 to 2. So we might as well start with x naught is equal to 1.5. We're going to have a bunch of values here that you need to write out. I'm not going to write them out for this walkthrough. And we'll start with 1.5. We'll hit enter. And we'll put in x sub n minus a nice little fraction here. We have x sub n to the 5th minus 2 over 5 x sub n to the 4th. And we'll hit enter. There's x sub 1. There's x sub 2, x sub 3, x sub 4, x sub 5, and it looks like x sub 5 and x sub 6 are the same. So we will say x sub 5 is equal to x sub 6, which is approximately equal to 1.148698355. And the next one is going to be an exceptionally similar problem. We're just going to say, all right, well, we want x to be the 4th root of 8. Well, that means x to the 4th equals 8, or x to the 4th minus 8 is equal to 0. So if x to the 4th minus 8 is equal to 0, we can call that f of x. We can say f prime of x is now just 4x cubed, and using Newton's method, we can approximate the root by doing x sub n minus x sub n to the 4th minus 8 over 4x sub n cubed. We know that f is continuous because it's a polynomial. And we know that f of, let's say, 1, f of 1 is negative 7. And f of 2 right? 2 to the 4th is 2, 4, 8, 16, right? So 16 minus 8 is 8. So we know that f of x must equal 0 on the 1 to 2 interval by the intermediate value theorem, right? And you want to state that that's how you're coming up with this great first guess of x naught is 1.5, because 1.5 is between 1 and 2. So we're going to have some values. You'll write them all down as we go through. I'm not going to, because that's a lot of switching back and forth on my screens. But we'll start with 1.5. We'll put in our formula, x sub n minus, and then in our fraction, the numerator is going to be x sub n to the 4th minus 8 over 4x sub n to the 3rd. And there's x sub 1, x sub 2, x sub 3, x sub 4, and it looks like x sub 5 is the same as x sub 4, so that'll be our answer. We got x sub 4, which is the same as x sub 5, was 1.681792831. And just one more here to go. We've got the cube root of 7. So we'll say x is equal to the cube root of 7, or x cubed is equal to 7, or x cubed minus 7 is equal to 0. If we call that f of x, then f prime of x will be 3x squared. We can write out Newton's method. X sub n plus 1 is x sub n minus x sub n cubed minus 7 over 3x sub n squared. We know that f is continuous because it's a polynomial. And we know that f of 1 is -6 and f of 2 is 1. Therefore, f of x by the intermediate value theorem must equal 0 on the interval 1 to 2. And so we'll start with our first guess of 1.5. And you'll write down all of them again, but I'm not going to. I'm just going to type it in here, 1.5, hit enter. We'll do x sub n minus our fraction here. We'll have x sub n cubed minus 7 over 3 x sub n squared. We'll hit enter. There'll be x sub 1, x sub 2, x sub 3, x sub 4, and x sub 5. Looks like those are the same. So our final answer is going to be that x sub 4 was the same as x sub 5, which was 1.912931183. And that is the end of our walkthrough for our Newton's method homework assignment.